Once again, z-scores tell you how far above or below the mean you are. When you're 1, 2, or 3 z-scores above or below your mean, then it's easy to use the 68, 95, 99.7 rule. When you're not a full standard deviation above or below your mean, then we need to use your z-score formula, where x is the data value that you have. We want to know how much is above or below that particular value. Mu is your mean of your population. Sigma is the standard deviation of your population. Now, if x is larger than your mean, then your z will be positive. If x is smaller than your mean, then your z-score will be negative. So let's consider our women's heights again. Normally distributed is what the n stands for. 64.5 is your mean, your standard deviation of 2.5. So what percent of the women are shorter than 67 inches tall? Well, our mean and our standard deviation, and we have our x being 67. So we could use our z-score formula. We can go our x, which is 67, minus your mean. Your mean is what we have of the 64.5 over your standard deviation of 2.5. You get 2.5 over 2.5, which reduces down to 1. So we have 1 standard deviation above our mean. Now, we can use the same idea that we did when we were looking at the heights of the men. You have 68% of your data being within 1 standard deviation. And then this right here tells you the area of both of your tails, but once again, we only wanted one of those tails, so that's why we take half of it. And then, because you're looking from 67 all the way to the left. And so you end up getting that 0.84 or 84% like we had when we were dealing with the men a little bit ago. Now, when it's not one full standard deviation above or below your mean, and it's part of a standard deviation, we then have to use table A in the back of your book, your z-score table. Now, the table in the back of the book always tells you the portion of data that's smaller than your data value, smaller than your z-score. If you had a z-score being a negative 2.40, you go to negative 2.4 on the left, and then you are going to be using that row going across. But then your second number after the decimal point is a 0, so you got to go to the second number after the decimal being a 0, and that's that first column. So we would say the area to the left, how much data is less than a negative 2.4, is 0.0082. So if you had a z-score being a negative 2.46, you go to negative 2.4, and then you got to go to the 06 column here, and where those two, the column and the row, overlap, that tells you how much data would be less than that z-score. Keep in mind that your z-score table, table A, the standard normal table, always tells you the portion of data less than your z-score, or always to the left. Now, let's use your z-score formula for that one that we talked about. We had figured out before our z was 1.00. So on table A, we can find 1.00. 1.0 then on the left. Then we want to go till our second decimal place is also 0, and to 0.8413. So we had said before that it should be about 84%, which it is. More precisely, using your z-score formula in your table A, we get 84.13% of the women are shorter than 67 inches. Well, would we be able to figure out what percent of women are taller than 67 inches? Well, yes, we would. If we know that this area over here is 84.13, we want to know the area above. All we have to do is subtract from 1. Because, remember, the area underneath your curve is always 1 or 100%. So we go 1 minus what we had from the middle of our table A, and that gives us then a 0.1587, or if you move your decimal point over twice, you get your percent of 15.87% are taller. So, what is a false statement here? Well, it's the units one. Remember, your z-score always tells you how far you're above or below your mean in standard deviations. If it's positive, you're above. If it's negative, you're below. A z-score has no units. Now down below here, we are wondering, or Marshall is wondering, I should say, how many SUVs are longer than his? Well, longer meaning more than, that would be the area to the right. If you're looking for shorter than his, that would be the area to the left. That would be plot A. But here we're looking for area to the right because you're looking for more than. Here we have a 60 or 670 with a mean of 600, standard deviation of 30. Plugging that into our z-score formula, you're going to get one of these two here, but which one's which? It is the one in the left. Remember, if your data value is greater than your mean, it's always going to be positive, and so therefore it's this one here. Also, if you just use your formula, you would end up getting that one too. Now, your um, table A and your normal distribution are symmetrical. If you're wondering about what data is less than a negative 2.33 on a z-score, you would get this. So therefore, what's greater than a positive 2.33 would be the same thing. Now, if you're looking for the area to the right of something, all you want to do is go 1 minus what you would get from the middle of your z-score chart in the back of your book, Table A. So now we want to know what percent of our students scored at least an 820 on the math and the verbal on the SAT. Now, in 2003, the mean was 1,026, standard deviation of 209. It's normally distributed. We have our mean right here, our data value, our standard deviation. We want to know what's above that, meaning greater than. So you want to be at 820 and you're looking for everything to the right of that. That's this orange area. Let's go ahead and plug our x, our mu, and our sigma into our z-score formula. We go ahead and subtract the top. Then we go ahead and divide. And we get a z-score being a negative 9.99. Well, we need to go ahead and look that up on our z-score chart in the back of our book. So we need to go to a negative zero point 0.9, which is right here. So we're going to be somewhere, whoops, in this bottom row. Sorry about that little blip. But when we take a look at our second one, that is, our second number afterwards is a 9. So then you got to go to the 09 column, which is this one here, where your row and column overlap. That's the number we're interested in, this one right here. So we end up getting a 0.1677, or about 16%. Well, we're trying to figure out what's above. We just figured out this white area here that we don't want is about 16%. So we need to go to the total area again whenever you're looking for above, which is 1, minus the area to the left. And that's about, then 1 minus 16% is about 84%. Once again, here's some tips on using Table A. Suppose you wanted to know the area between two values. Well, you'd want to do the z-score formula for the first value, z-score formula for the second value. Go to Table A, find out the number in the middle of the chart for each z-score. Then subtract the two numbers in the middle of the chart. The middle of the chart for the big z-score tells you what's the left of this one here. The second z-score in the middle number in the middle of the chart tells you what's to the left of this one here. We want to know what's in between, so we subtract those two areas. Make sure that you do not subtract the z-scores themselves. Subtract the portions of data from the middle of your chart. So, partial qualifiers score at least a 720. But we know if they're an 820 or above, they are fully qualified. So what percent of our students are partial qualifiers? So we need to figure out what percent of the data is between an 820 and a 720. So all we have to do then is do our z-score. We don't really have to do the z-score and figure it all out for the 820. We did that on the previous couple of slides. So now let's figure out what's the left over here. Well, when we do that, we plug in our 720 for x, our mu being 1026, our standard deviation sigma being a 209. We plug that into our formula. We subtract the top. We go ahead and divide. We get a z-score being a negative 1.46. So then we want to go to table A. We need to go to a negative 1.4, which is here. We need to go to our second digit, which is a 6, and that would be this one here. And you want to look at where those two rows and columns overlap, and that would be this number right here. So we'll go ahead and write that down. It's almost 7%. Now, we had figured out the area to the left of the 820 before, a couple slides ago, being this. Area to the left of the 720 we just figured out, and that's the 0.0721. So we have to subtract those two to figure out the area in between, and we get almost 9%. Remember to go from a normal number to a percent, you subtract these two and then move your decimal point twice. Now, the cool thing about z-scores is it really does allow you to compare apples to oranges. You probably have heard the saying before that you can't compare apples and oranges. However, with z-scores, you can truly compare apples and oranges. So let's consider the situation here where we're dealing with pregnancies. Now, we have two groups of people, one where they received vitamins and better care, and then the other group that only received vitamins. And so now with that group of vitamins only, we want to know what percent did not make it to the 240, the 8 months. And we want to figure out for the orange group what percent did not make it to the 240. And you can see with the orange group here, it seems like it's a smaller area than the blue one. But let's go ahead and use our z-scores to find out more. So we're looking at the blue group. Our mean was 250. Our cutoff for the preemies is 240, standard deviation. We go ahead and we get a z-score being a negative 0.5. Using your table in the back of the book of table A, you get a negative 0.5, so you go to negative 0.5 on the left over to the 0.00 column, which is the first column, and you get this. So about 30.85% of the women were expected to have their child earlier than 240 days. So let's go ahead and do that also for the vitamins in food. Our mean there was a 266, standard deviation 15, so we plug that into our z-score formula, subtract the top, go ahead and divide, and we get a z-score being a negative 1.73. So in the table in the back of the book, go to a negative 1.7 on the far left-hand column, then go to the O3 column, and where those two overlap, you end up getting only about 4%. So with the vitamins and food, it's about a little more than 4% of the women end up having preemie babies. So vitamins and food was only 4%, vitamins only was 31%, so therefore the vitamins and food definitely helps.